1 second. Okay, we are live on StreamYard, LinkedIn, YouTube, and X. So it looks like
Awesome.
people are trickling in. We'll give them a few minutes. But Austin and Darian, thank you so much for joining us today to give us a demo on Kimi K3.
Thanks, Grace. Really appreciate it, and super excited to be doing this today. It's definitely K3 has been on the tip of everyone's tongue for the past couple of weeks. So always exciting getting to do webinars and things like that that are about topical, very, very current subjects. So very neat. Curious
Awesome.
where folks are coming in from today. I'm sure we've got folks all over the world. Just go ahead and put in chat where you guys are connecting from. I'm curious. I always like to figure out who's the farthest person away. Norway, 2 from Norway. Okay. Maybe
That's
2 guys in
impressive.
the same office there.
Argentina, Denver, nice.
Got
Very
a
cool.
Denver. I dig it. Yep. Also Denver here. I'm based out of Denver. Austin is based out of Saskatchewan. SF Bay Area. That makes sense. Hey, Sam, I remember you. Haven't gotten to your LinkedIn message yet. Sorry about that. I'll get back to you soon. It's been a busy few days since the conference. Chile, that's cool. India, awesome. Brazil, Utah. Where else? Where else is everybody coming from today?
Very cool.
Vienna. Oh, that's nice. Definitely
Wow, guys,
on my list of cities that I want to visit, Vienna.
I was going to say thank you for staying up late or waking up early to join us. It means a lot that you guys wanted to hear us talk about Kimi.
Absolutely. Pakistan, North Carolina.
Cool. Okay, we're a few minutes past 11, so I think we can go ahead and get started. As you guys know, Darian and Austin will be talking to us about an app they built with and without Kimi so that we can see the difference. Austin is a senior solutions architect here at DigitalOcean, and Darian is a senior manager. So you guys are in great hands and going to learn a lot. And they have a jam-packed agenda for you. They'll introduce you to the app they built, take you through the cost problem of building it, show you a head-to-head comparison and the math and measurements behind it, tips and tricks they have from building it, and then we'll open it for a Q&A so you guys can ask some questions. So with that, Austin and Darian, I'll kick it over to you for the demo.
Awesome. Thanks so much, Grace. Yeah, looking forward to it. So we were excited about Kimi coming out, just like everybody has been. As I mentioned, it's been on the tip of everyone's tongue for a couple of weeks now. And so we were looking for a way to try it out, to test out Kimi and see what it can really do. And we happened to be working on the perfect use case for something like this at the time. I want to introduce you to Poseidon. So let me take it back a little bit and come to why we did this. The reason that we built Poseidon is we realized that most of our builders, people working on DigitalOcean, are currently using an agent to manage their infrastructure, a harnessed agent, something like Claude Code or Codex, something that is doing things for them. You give it your API key, it can stand up infrastructure for you. We've built agents to run on the front end to help with people solving problems, but when you're working with a harnessed agent, that ends up being like you copying and pasting between 2 windows on your browser, and that's not a very good experience. So what we thought about is, what if instead your agent could talk directly to DigitalOcean's agent and escalate those problems and get them solved one-on-one. So we built Poseidon. What Poseidon does is he operates on something called Coin, which is a secure agent-to-agent protocol, and it allows him to peer with your agent in a way that your agent can ask Poseidon questions directly. So as you are building something on DigitalOcean, you're talking to your agent, you say, I want to stand up an app platform app. Your agent then calls out to Poseidon and asks, hey, this is what we're doing. What do you think? How should we build this? How should we architect this? Any advice? Poseidon then reaches into his massive corpus of information about DigitalOcean, which we keep updated so you don't have to, and then responds to your agent with a solution, with an answer, with hopefully a helpful response. This supercharges your agent. We're going to try and get benchmarks about how much it supercharges your agent later, but for now, that's not the point of the session. The point is, we realized what we're doing essentially is rerunning every query that you're asking about DigitalOcean to your agent. We're rerunning it on Poseidon and then sending you back the results. So if we're going to do that, we have to do it in a cost-effective way. So it was perfect timing for Kimi to be coming out right now, because we thought, okay, if we can reduce our cost per token while still providing the same level of quality and speed to our customers, then that's an obvious win. So let's take a look at just how that performance looks.
All right, thank you, Darian. One moment here, let me just switch it over to my tab. Yeah, so we built this dashboard here called the Regatta because we love nautical themes here. For those of you who might not have heard the term before, a regatta is a type of boat race. And so we've got some preloaded prompts here that use our knowledge base that we've configured in DigitalOcean to work with these models to answer these preset questions here. So I'd like to show you some of these questions here, show you how we score them, and then evaluate why you'd pick one model over another one. So I'm going to go and I'm going to ask all three models here. And you can see right away, Kimi K3 is able to answer right away. Claude Opus 5 is right behind it, very quick as well. Kimi K2.6 took a fair bit longer. We're seeing for metrics here, 0.72 seconds, 2.57 seconds, and 6.44 seconds. That's a pretty wide variance actually here, but the real interesting number is the cost. We're seeing here that it cost about a quarter of a cent on Kimi K2.6, a cent and a quarter on Kimi K3, but almost 4 cents on Claude Opus 5. That will scale over time here. And so I can go and actually grade these answers too using evaluations on the DigitalOcean platform that evaluates the knowledge base. And it goes and evaluates for correctness and faithfulness. Darian will expand more on that in a later section of this webinar. But for now, I would just like to show you what it looks like when it's rating these and discuss the answers that it's providing. So we can see that all these agree on what the core answer is. Kimi K2.6 is fairly light on the details. Kimi K3 and Claude Opus 5 both provide technical information. They all scored about the same. This one wins on brevity and cost. But you can see here they all scored perfect on correctness, and they were all 90% faithful. So these questions do get harder the more I scroll down. So let's try a couple other questions here too. So for example, which URL do I use to chat with the GenAI platform agent? So it's going to provide the inference endpoint here. And all of this could be provided directly to your agent too. Like as Darian was saying, we want to reduce prompt duplication, and we want to provide the information that is useful for your agents to leverage, not just what a human might necessarily need too. So you can see here that here's the technical information that would be required. Here's what a curl example would look like. And you can see that Claude Opus was not able to use RAG for it, so it did go and search it for itself, or from its own knowledge there. We can still see that Kimi was significantly faster, and that the cost was about 1/4 of what it cost in Opus 5. Well, we're still waiting for Kimi K2.6 to respond to us. We'll give it a bit to respond here. The reason why Kimi K2.6 is taking so much longer is because of how RAG gets structured and how RAG impacts the prefill versus decode phases of prompt returns, basically. So the prefill phase is what happens before the first token gets set. When you're doing prefill, it's basically building its initial corpus, and then when it's the decode phase, it starts streaming all the subsequent tokens after that. Now that it's finished, we can see that it actually failed in this one. It did not actually pull the correct information at all. So I'm expecting it to do very poorly when we grade the answers here now. Going back to RAG for a second, that's why training something into the model is more effective. Something I would love to do down the road would be to train a custom DigitalOcean agent to answer these types of questions. But we do provide the tools to enable RAG and make it easy to get going and build these types of products and tools very quickly. So
this is, if I can just jump in for a second, sorry, Austin. I think that this is one really compelling reason why we wanted to build Poseidon, is that this curating of all of this knowledge and making sure that it's all in one place and that it's updated and that old stuff is ejected and that you review it for quality. This is stuff that we don't want you to have to do on your side. So if we give you an agent that does that for you, that's the hope, that you can integrate that easily.
Exactly. And we can see here that Kimi K3 got a perfect score. The other models did not. Kimi K3 absolutely nailed this question based on our evaluations. So let's scroll down for a bit of a harder question here. Let's go with what built-in metrics are available. That's always an interesting one because that can expose a lot of useful data for agents and for humans both. So it's going to go and run the query against it. It'll go and retrieve the data it's required through RAG. And so we can see here that you can define custom metrics. You can go for different presets, different evaluations here. It will give you more information about how your queries are running and what's occurring within your data set. So you can see on the Claude side, I feel like Claude did do a better answer on this one here. It's given more specific information about this, but that may be a hallucination. I'm not sure yet. It's very confident right now. We'll see what happens when the answer gets graded and how faithful it actually was here. We're still waiting on Kimi K2.6, as I said, because of how RAG works, and just Kimi K3 is significantly more efficient for RAG operations than K2.6 was. But here we go. It's done prefill. Now it's decoding. It's streaming the tokens to us. And we can see it took almost 44 seconds. And yeah. So let's grade these now. So while it's running, let's just take a look at the cost here again, because that's what we keep circling back to. One of the things that we keep on coming back to for pricing is pricing per million tokens. We hear about that a lot from customers. We'll discuss that later on in this presentation too. But really, tokens per or dollar per million tokens is not always the right metric to focus on. What you're really concerned about is dollar per task, regardless of how many tokens were required to complete it. And so actually Opus was correct here. We can see that it was the most correct and the most faithful here. So that's why these evaluations are so useful, and that's how we can ensure that we're not having drift, knowledge issues, et cetera, et cetera. Let's go with one more really hard question down here from the bottom here, and then I'll ask it a custom question. So let's go with this one, actually. This is an interesting one. And so I'm a big metrics guy. I very much believe that you need to be making data-driven decisions. So if you can't benchmark it, it's not worth anything. So I'm a big fan of Dora metrics and similar frameworks too. And I want to see similar types of organization come to AI workloads as well. We're seeing some of that already with time to first token, tokens per second, teapot metrics, that kind of thing, such as this one here. So teapot, time per output token is the inverse of tokens per second, basically. We can see that it answered very quickly here. It answered, again, very cost effectively, and it was able to do it at a much lower tokens per second than either of the other models required. So that's where Teapot comes in as well. So we'll go and we'll grade these now, and we'll see how they all score for their answers. I strongly prefer the Kimi K3 answer in this case over the other two.
If I can just jump in again, Terry had a question in the chat from LinkedIn. Thanks for asking, Terry. Yes, this is a live demo. Yes. Against the advice of our marketing team, we decided to do this live because we're that excited about it and we think it's a cool tool. I will say that obviously this page here is DO login only because it does take a lot of tokens to do what it's doing here. That's why we provided the GitHub, and I'll provide a link again at the end to that GitHub page, but you guys can go and deploy this yourself and test out these models yourself. You can also change out the model if you want to run different types of regattas. So definitely this is a live tool and working so far, so that's good.
Yeah. So I'm not going to be able to grade this one because this is a custom question. It's not going to bounce off against our evaluation set, so I can't actually grade it afterwards. But I'm confident that I can look at this code and figure out which one I prefer here as it gets produced. I'm a Python guy. I've been writing Python for, I'm dating myself a bit here, but almost 20 years at this point. Yeah, so I can see which one of these would be the one that I prefer to work off of here. So looking at these, let's go to the top here. Well, actually, gotta wait for it to finish decode, or else it'll just keep bouncing me back to the bottom here. Even just looking at how this is going side by side, though, I'm already preferring the Kimi code. It's just a lot cleaner to read, and it's got better helper functions. So it is taking longer this time. This is actually the case where Kimi's taking longer than the other, or where K3 is taking longer than the other two models, but it's being very thorough, and it's providing some pretty good answers here. So as we can see, it took 3.63 seconds for Claude. It took 17.3 seconds for K2.6, and K2.6 was actually the fast one in this case. But it's very minimal. This works technically, but if you hit anything that's off the happy path, if you run into anything like an SVG file or anything similar to that, this is going to break very quickly. Like, this is fine as like a starting point, but as soon as you encounter any edge cases, I can tell this one's already going to break pretty quickly. Now looking at Kimi K3 versus Opus 5, right out of the gate, I can see that the imports are a lot cleaner for Kimi K3. I've got far fewer imports here. It's defining different object-oriented paradigms here in order to make things easier to maintain. It's setting up its init correctly. It's setting up different helper functions here. This is a very repeatable design. There are some helper functions here. There's some handlers here on the Claude side, but there's a lot of nested if and elif in here too, and I don't love that. It's very thorough, but that would be a pain to maintain. This is looking already a fair bit more maintainable. I would have no problem letting my agent manage the Opus 5 output or maintain it for me, but for Kimi K3, if it's code I want to maintain myself or work with directly, this is looking a lot better personally. And so they also do call out different key features that they're leveraging, what their caveats are, how to work with them. They're both very, very high quality outputs. It just comes down to whether you're worried about cost, whether you'd like your agent to maintain it, what your latency requirements are. There isn't necessarily a right fit for all applications, of course, but this does help us size the right model for the right application. And with that, I would like to pass it back over to Darian to discuss what our podium over here is.
Thanks, Austin.
Yep.
Yeah, obviously really cool to see all of these run side by side. But I think the bigger question we wanted to answer is, what does this look like over all the questions, right? What are the averages? What is, when you're giving it all these different questions, how are they performing on average? Because you saw there were differing answers, differing levels of results per question. And it's also non-deterministic. So this is one of the reasons we provided you guys with a GitHub page where you can run this yourself, because we want you guys to be able to run your own evaluations and see what sort of answers you get. We'll talk about some of the gotchas for that at the end here so that you guys don't run into those same barriers. Or if you do, at least it's an easy one for you to climb. So let's look at the headline. These numbers up at the top, I think, are pretty telling. Over all 57 questions that we gave it, Kimi K2.6 with our knowledge base is 86.1 of 100. Kimi K3, 89.2, and Claude Opus, 88.2. Now, this is a 1-point difference between K3 and one of the top frontier models right now that was just recently released. I don't think that is a significant difference, right? We're essentially, I would call that similar performance. Pardon me. So that's important, because if we go down a little bit to these numbers, additionally, I should call out faithfulness versus correctness. Let me take a second here to talk about faithfulness versus correctness for anybody who isn't familiar with those terms. Correctness means, was the answer accurate based on the facts that it had available, and did it answer the question that was asked, right? So are you giving the correct information? Is it correct? Is it what they asked for? Faithfulness, on the other hand, is essentially a hallucination measure. Lower is worse. So if something is high faithfulness, it's not inventing any information. It's not doing anything unsupported. Now, I don't want to say that just because it's not got 100 faithfulness that it's hallucinating, but it may be adding things that the judge can't verify by the documentation that it sees. So it could be that the agent knows something else or looked up something that the judge didn't see. But the point with that is that an agent with, for example, 100% correctness but 0% faithfulness will give you all the right answers, but interspersed with that will be some crazy hallucinations that it's inventing. The opposite end, an agent that's got 100% correctness and 0 faithfulness, will give you no answers, and it'll tell you it knows nothing because it's trying to be honest with you, right? So that's sort of the way to think about those two numbers.
So to be clear then, Darian, if something has high faith and low correctness, it will just say, sorry, I can't answer that. But if something is high correctness and low faithfulness, it'll give me all the answers I'm looking for, but it's going to lie to me a whole lot in the process too.
Yes, sorry, maybe I misspoke there, but yeah, very, very useful measure, and it's one of the things that we wanted to build into this. That faithfulness score, I just wanted to call out, also statistically insignificant difference, right? We're talking about 71.2 over here to 72.5. Not a difference that you're going to notice, probably going to get washed out over a large number of runs of a tool like this. So overall, those numbers are very similar, correctness and faithfulness. And then we look at cost per answer. And that, I won't make you guys do the math, is less than half of the cost per answer of something like Opus 5. And this is open source, right? So you can, if you want, you can run this on dedicated hardware. You can do whatever you want with this, and you don't have to go to a third party to do it. And latency, I'll just also call out relatively the same. We do see more latency with Kimi K2.6, but on average, you saw sometimes Kimi came back right away. Kimi 2.6 came back right away with the answer. Sometimes it took longer. On average, it's about the same window. We'll talk about that a little bit later. But I wanted to show this in a graph with correctness and faithfulness. And I wanted to show this graph because it doesn't really show you a difference, right? We can swap between correctness and faithfulness here. They're basically the same. The only difference is the cost, right? 2.6 way back here at a quarter the cost of K3, K3 over here at less than half the cost of Opus 5. This is a meaningful finding. It means that you can probably swap out K3 or even 2.6 if you're less latency sensitive for a frontier model, still get that same quality, but for half or lower of the cost, which is pretty cool. And then here's the latency chart down here. I did want to mention that obviously the trade-off with Kimi 2.6 is it does think a little harder. It takes a little longer sometimes. But even with all that extra thinking, it's giving you lower cost per token, significantly lower. As well down here, if you want, when you run this on your own, you can dig into each specific answer, see where all of them were failing, for example, in the run, whereas all of them were succeeding. You can also switch this between correctness and faithfulness to see the heat map. The big number, though, that I wanted to go over is this cost at scale down at the bottom. So like we talked about before, cost per million tokens isn't necessarily a good metric. It's not useful because the question is how many tokens are you using per task or question, right? So what we really want is cost per question or cost per X questions. And so that's what this slider down at the bottom gives you. Originally, we had multiple graphs for different numbers of questions per month, and then we realized the ratios are identical. So we might as well just add a slider.
Linear scale bites again.
Yes. So when you get to 1 million questions per month, you can see roughly what this means for your business or your app or your coding tool. On Kimi K3, you can get comparable quality, comparable speed, and comparable faithfulness for less than half the price. That's the headline, folks. So when we were looking at what should we run Poseidon on to answer y'all's questions, Kimi K3 came out as the obvious answer. We can answer twice as many questions and still be under the cost of running this against a frontier model. So that's overall the metrics that we found. I did want to go over at the very end here some of our findings in terms of gotchas, because if you guys are going to run this demo on your own, I want to make sure that you don't run into the same pitfalls, or at least you've got the rope to help yourself out of that pitfall once you hit it. So reasoning models are a special kind of model. They do a lot of thinking before they actually render output. That means a couple of things. One, if you have a tight token budget, you can actually cut off the model before it's even done reasoning. We found that we had a too low of a token cap, 1024, on our first runs of this. And when we raised that to 4096, we were able to get all the way to from 33 correctness to all the way to 92. So it makes a big difference in terms of correctness with a reasoning model. Additionally, if you do run into empty replies with finish reason length, that's the problem you're experiencing. You have a max tokens budget that is too low, and it's handicapping the reasoning model. So
and just to add on that too, if you want to benchmark this against other models and other model families, make sure you check the output format as well. Harmony models like GPT OSS will produce different outputs from Kimi, from Quen, et cetera, and that can often be like a strange breakage point.
That's a good call out. Was my next slide here. Thinking streams in a different field for Kimi. And this may be for other models as well. We'll get to standardized points at some point in the future. But if you're looking for what's going on from a thinking perspective, you need reasoning content, not delta.content. Okay, so if you just read delta.content, it's going to look like the model's not doing anything. I should note the live race supports thinking. You can add the thinking stream to the top of that. We collapsed it because it wasn't that helpful for this demo, but we support that. It's just a feature you turn on in the demo where that we've posted from GitHub. Another problem is that if you're using an LLM as a judge, there are some things that you should be aware of. One, If you are, again, reducing the token counts of your judges to try and save costs, understand where you're coming from, but you're probably not going to get good judging results. So strongly encourage everyone to raise the judge's token budget so that you can get good, meaningful results from that judging. Additionally, one thing that somebody called me out on early on was I was using Kimi to grade Kimi's own output. Okay, that's fair. They're probably going to give themselves a good grade. So instead, you should use another third-party model. So in this case, since we're using Anthropic and Kimi, we decided to use DeepSeek as the judge model in this case. And then finally, on the judge side, judges have a noise floor. And by that, I mean they can read identical text. And because these are non-deterministic tools, they can come up with different outputs. We found with DeepSeek, we were seeing about a 10-point plus or minus. So understand what that noise floor is, as we call it, when you're using a judge so that you can get statistically meaningful results. If they're 1 point off, it may not be a really meaningful result there.
And Darian, just pause here for a second here. I'd just like to expand a bit further on what Darian mentioned there around determinism. What we mean by determinism is that it's going to be mathematically equivalent on the output. LLMs specifically do not do this. LLMs are non-deterministic, and even asking the same question twice to the same model can produce wildly different results depending on various factors like RAG, on time of day, on a whole bunch of other factors going on with that. And so we talk about a term called idempotency as well, which is if I run the same output, do I get the same output every time? A flow I'm seeing more and more frequently is that agents will have deterministic flows they can lean on so they can judge for them when they need to use those deterministic tools themselves.
Absolutely. Thanks, Austin. And then finally, for LLM as a judge, just because you've successfully indexed doesn't mean that all of the stuff in your index is valuable. This is something we found when indexing our documentation. There were a lot of API stubs and things like that that were not useful for the corpus. This is one of those things we said before. This is why it's useful for DigitalOcean to maintain its own agent with a KB, because then you don't have to sort through all of this fluff yourself. Oh yes, good answers. Thank you for that. And to that point, it's a $3 per million tokens. Like we said before, not my favorite metric, but we have to know what your tasks are before we can say your cost per task, right? So this is why we're releasing this publicly, this tool, so that you guys can put in your own model keys, try this out with your own tasks put in, and see how those models perform against your own tasks. So that way you can measure out your actual cost per million tasks. And then finally, just a couple of things on platform deployment. So some platforms will do what's called SSE buffering and server-side events buffering. And this can make it look like the application is slow or stopped or not performing at all, especially when you're receiving a stream of tokens. So if you find that on any platform, especially like container platforms often do this, that this application is not running as you would expect, I would recommend you run it on a VM directly so you have more control over that stream buffering. Mm-hmm. And then finally, most model pricing is machine readable. You do not need to hard code this stuff. So you can read it directly from the provider. It's just not worth trying to hard code. That way you can easily switch between providers. API is probably going to be the authoritative source.
And that's really great when you got new models too. Like there's always new models coming out. That's a living document that you can keep your agents updated with.
100%. Pardon me, folks. The point here is cost effectiveness. I think we proved pretty clearly that you can get frontier level performance from an open source model, which to me makes it a frontier model, but it's not closed source, so I don't know how you define that. So this is a really compelling argument for your use case. If additionally you do want that extra little bit of oomph from a frontier model, but still want to use something like Kimi for other requests, for the general requests that you have, you can use our model router. It's a pretty cool tool. You should check that out on DigitalOcean. I've given you 3 links here. One is the link to talk to Poseidon. Just give your agent that link and they can handle the rest. 2 is the harness itself that we've shown you here today. This has everything that we've built here. And then 3 is a link down at the bottom to start building on DigitalOcean. That's just a login page for DO.
Okay, and just before we close things out here, just 2 other points I'd like to raise that unfortunately we just didn't have as much time to get to as I would have liked. Kimi K3 is a multimodal model. You can do visual work with it as well. We just didn't have time to integrate that into this demo here, but later on you'd be able to present in diagrams, have it do analytics on that kind of thing. Brad Thompson, that actually was exactly going to be my next point too. Our model router does not work like OpenRouter. OpenRouter works between different providers. We route you to specific models within our platform. One of the key features we offer is the ability to set a fallback model based on different tasks. So we can functionally let you set up a router, select the models you want to attach to specific tasks, and if the task that comes in does not match any of those, it falls back to a large effective model like Kimi K3.
And just to clarify on that as well and make sure that the point is super crisp, OpenRouter will let you choose a model like K3 and say, I want to route between different providers based on latency or cost for tokens on K3. What our model router will do is it'll allow you to find different types of tasks that your application may be handling, and you can send those different task types to different models. So that way, for simple tasks like documentation lookups, you can send those requests to a lower cost model, whereas more complex questions you can still send to the frontier. So that allows you to not only control your cost, but the quality of each of the responses based on the type of tasks that they're handling.
And it's easy because it's one endpoint and one key.
It's dead simple. Yeah, I strongly encourage everybody to try it out. It's really cool, and it works like a charm. So if you haven't tried it out yet, go give it a shot today. Thank you, Grace.
Thank you, Grace. All right.
Awesome. Thank you so much, Austin and Darian. I'll bring up those resources again. If anybody has any questions similar to what Brad asked, we'd be happy to answer them. Or if you want to get started, here are those links again that Darian mentioned and Austin in their demo.
Yeah, folks.
Yeah, any questions, please feel free to ask, folks.
Yeah. Yep. We've got a lot of knowledge here. I think between the 2 of us, Darian and I have been in DigitalOcean for about 15 years between the 2 of us at this point.
Yeah, I just passed my 10-year anniversary in April, which is pretty crazy. I mean, in tech company terms, it's like I'm a dinosaur.
Yeah. Yeah, I'm at 6.5 at this point now. Grace, can you confirm the recording will be available later on?
Yes. So this will be available on YouTube, and we'll be sharing the links out with anybody who registered for the event, or you can go check it out on our DigitalOcean channel. Darian and Austin, have you guys used Kimi to build anything for fun outside of this demo yet?
Absolutely, yes. So I mentioned earlier on that I'm doing a lot of like cross-agentic workflows and enabling multiple agent operations. And so I've got basically a simple hub and spoke design where I have agents that are working with cheaper models feeding into a centralized agent running Kimi K3 and having that one do analytics on the reports it finds.
Cool. That's very interesting.
I do see a couple of questions in the chat.
Yeah. You want to take Terry's first?
Yeah. So Terry, we don't have a free tier right now, but if you reach out to me and we can talk a little bit about your use case, I can throw some credit on your account as a thank you for showing up to our webinar today and asking some questions. So please hit me up. I'm dwilkin@digitalocean.com or Darian@digitalocean.com because I've been here that long. As well, I see there's a question. Do you have data centers in Europe? Yes, we do. We have London, Amsterdam, and Frankfurt data centers.
Yes. Yeah. Oh, and also just one thing I'll put out there too, like we love open source tooling. We love infrastructure as code here. This all works with like our Terraform provider too. And yeah. Yeah.
Big fans of open source at DO. Every product that you see we have it's based on open source. Even the model router that we have, we've released it as an open source tool. So anybody can play around with that model router if you want to set it up yourself.
Yes.
Awesome. I just put, Darian, your LinkedIn information in the chat. So if people want to connect with you to learn more, feel free to shoot them a message.
Thank you so much, Grace.
I'm so glad you asked, Brad. That is actually specifically the project I'm working on. I'm doing a lot of heavy work with Hermes. Yes, it works great with Hermes. Can you use Poseidon test your own reg? Yes, you'll need to do some extensions on it. You'll need to build your own evaluation suite. But yes, we've provided the base layer for it, and you can absolutely accomplish that with some tuning and some changes.
Yeah, once your peer-to-peer is set up through Coin with Poseidon, you can have your agent write out an answer based on its RAG, and then send that answer to Poseidon for a comparison. So go ahead and give that a shot. Let me know if you have any issues. Something we've been working on. So definitely expect would love some feedback.
Nice. Thank you guys all for such great questions and engagement during the session. And Austin and Darian, thank you guys so much. You crushed it, and this was really entertaining to watch. So thank you.
Thanks, everybody. Been a pleasure.
Yeah.
Thanks, all.
Like I said, this will be available on YouTube, and we'll also send all the registrants to the recording. So thank you so much for spending your Wednesday morning with us.
Thanks,
Bye, everybody.
Bye.